Okay, so conditional probability. So we start off with an example. So a white die and a black die are rolled. A, calculate the probability that the sum is 6. Okay, so we can do that. Make sure you're writing this down because I'm going to erase it, okay? The probability of event A, we'll call this event A happening. The probability we have a sum of 6 equals, well, let's see, how many ways can we have a sum of 6? 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. Those will all add up to 6. So we have 1, 2, 3, 4, 5 ways our event can happen, divided by 36 events, or outcomes total. Okay. Put that in your calculator, make sure you get 0.139. Okay, so we should all be okay with that. Part B is where we're going to introduce a new way of thinking, okay? So calculate the probability that the sum is 6 given the black die is a 2 or a 3. Okay, so first let's create a little legend for ourselves. Let's say the first number is the white die and the second number we see is the black die. Okay, as we see here, white then black, okay? So how should we do this? Calculate the probability. The sum is 6, given we know that the black die is a 2 or a 3. Okay? So how we write this notation is we say the probability of A given B. But what we'll use in this course, the shorthand, well, it's used in more than just this course, but the shorthand for given is probability of A and then a vertical line given B. Did we see this already before, the given side? Not yet? Okay. I wasn't sure if we touched on it in units 1 or 2. But yeah, so this reads, what's the probability of A happening given we know event B has already happened? So here we can say rolling a sum of 6 is event A, and the black die being a 2 or 3 is event B. That would equal, well, let's see, where's all of my rolls where the black die is 2 or 3? So that would be here, right? So in that square, or rectangle, right, the black die is either 2 or 3. All right, so given we know something in that square happened, what's the probability that we have a sum of 6? Well, we have 2 outcomes in that square that are a sum of 6, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outcomes total. We ignore all of the other outcomes because we know something in the rectangle has happened, right? That's what we're given in the question. Given this happens, what's the probability of something here happening? Okay? All right, so if you put that in your calculator, right, that's 1 over 6 or 0.167. Any questions there so far? No? Okay. So you see how our denominator, right, when we're doing our probabilities, is lower now, right? Right, our sample space is restricted because we're given that something happens. Okay? And we'll formalize that a bit more over here. formula for conditional probability. So just to review, we know the probability of any event A happening by itself equals the number of ways our event can happen divided by the total number of outcomes in our sample set, okay? But our formula for the probability of some event A given some event B has already happened. Make sure you're reading left to right, okay? Never say B given A. Probability of event A given some event B has happened equals, it's going to be the number of ways event A and B can happen together divided by the number of ways event B can happen by itself. All right, so your formula, it's always the intersection divided by the number of ways you can have the second event, or the event after the line, or the event that has definitely happened, okay? So you can do it the number way, or if you were dealing with probabilities, you would say the probability of A and B happening at the same time divided by the probability of the event B that has already happened. Okay, so if you refer back to question 1, right, that's kind of what we did. We restricted ourselves to that second and third column, okay? So we said the number of ways A and B can happen together was where our diagonal line and that rectangle intersected. There was 1, 2, the 4 and 2, and the 3 and 3. And then divided by the number of ways just B can happen, those two, the second and third columns, which was 12 ways. Okay? All right, but this is going to work for any conditional probability problem. So we can clarify here. Right? Everything outside of B is not possible because we know B has definitely happened. Therefore, it narrows our sample space, down to outcomes inside of B. And that's why we have just the probability or number of ways B can happen in the denominator, because it narrows our sample space down to outcomes inside of B. Any questions there? So people finish writing that down.